Hello everyone, and thank you for joining us today. This is a Surfer 12 webinar on creating and using BLN files. My name is Carrie Dickinson, and I'm the Surfer Product Manager. I've been with Golden Software for over 15 years, and I'm here today to go over some questions about BLN files and how to use them in Surfer. Specifically, the questions I'll be reviewing are, why would I use a BLN file? What is a BLN file? How do I create one? And how do I use a BLN file once I have one? After the discussion of each topic, I'll have time for 1 or 2 questions. You can send your questions to the webinar host via the questions box on the webinar control panel. Type in your question, and it will be sent to the webinar host, who will then forward it to me. So please send in your questions, but if I don't get them, I'll follow up with an email after the webinar is completed. The webinar will also be recorded, so after the webinar is finished, if you missed anything or want to rewatch something, the video will be available to view on our website at www.goldensoftware.com. So let's begin. The first topic I'll cover is why would someone want to use the BLN file, which is also known as a blanking file. So why are these files even important? Now, BLN files can be used in Surfer to blank outside or inside polygon boundaries. It can be used to delineate fault lines or break lines when grading data. And you can also use them to slice a grid file to create a topographical profile. Now, to use these functions in Surfer, the polyline or polygon boundaries must be saved in a BLN file format. No other file format can be used for these functions. Now, BLN files can also be used to create base maps of points, polylines, and polygons. However, you can use other file formats to create base maps. So out of these uses, blanking is by far the most common use for BLN files. But what does blanking actually mean, and why would you want to blank a grid file? So blanking is a way to convert areas of the grid file to a null value. You're not cropping or cutting out portions of the grid file. The grid nodes are still there in the grid file, but the Z values for those nodes are just converted to a node data value. And so they're ignored when creating maps or calculating volumes in Surfer. For example, this map here was blanked outside this polygon boundary. And so you don't see any contours drawn outside the polygon. Now, this is a good way to show map data just within a particular boundary, like contours inside a building or within a field area, or you can constrain bathymetry contours within a lake boundary. Alternatively, you can also blank the grid inside the polygon boundary. So in this case, you wouldn't see any contours inside the polygon, and they would all be outside the polygon. So I'll go into these use cases in a little bit more detail later on in the webinar. For now, I'll go into what the file format actually looks like, how to create one, and then talk about how to use it for these situations. Before we move on, are there any questions about why you would want to use a BLN file? No? Okay. I'll go on to topic 2. The next topic I'll discuss is what actually is a BLN file. What does it look like? So a BLN file is what we call a blanking file. It's Golden Software's vector file format, and it's a simple text file format containing point, polyline, and polygon features. Each of those features can have one attribute associated with it. You can create, open, and edit BLN files in any text editor like Notepad, Excel, or even the Surfer worksheet. The Surfer worksheet is probably the easiest for BLN file editing, and I'll go ahead and open one in the Surfer worksheet by clicking File, Open, selecting the BLN file, and clicking Open. So it opens in the worksheet, and here you can see what the file format looks like. In this BLN file, there are 3 objects: a polygon, a polyline, and a point. So each object in the BLN file consists of a 1-line header row, followed by a list of the XY coordinates for that object. The X data is in column A, and the Y coordinates are in column B. Now there's an optional column of data here in column C. Now this would be the Z values for the respective XY point. Now, but this column here, in column C, this data is only used when using the BLN file as a breakline file when gridding. Otherwise, this column is ignored, and you can leave it blank or have anything in it that you want. The header row contains the number of data points in the object in column A, a blanking flag value in column B, and the attribute for that object in column C. Now, the number of data points in column A is required. The flag value in column B is only used if you're going to use the blanking file to blank a grid file. If you were going to use the BLN file to do something else, then you don't need any value in column B here. Now, if you were going to blank a grid with this polygon, the blanking flag value tells Surfer to either blank inside the polygon or outside the polygon. You would enter a 0 if you wanted to blank outside the polygon, or a 1, I could change this to a 1 if I wanted to blank inside the polygon. Now, I can usually remember this because a 0 looks like an O for outside, and a 1 kind of looks like an I for inside. But if you aren't using the BLN file for blanking, like I said, then it doesn't matter what you have here. You can leave it blank if you want to. The attribute value in column C is purely optional. You can include it or not. For this file, I added the object type as the attribute value. So let's walk through this file pretty quickly. The polygon object is first. There is a 7 in cell A1 to identify that there are 7 vertices in the polygon. Then the XY coordinates of the 7 vertices are listed. There is a 0 in column C, so if I did use this file as a breakline file, that would be the Z value for those XY vertices. And in this case, the first set of coordinates in row 2 and the last row of coordinates in row 8 are exactly the same. This tells Surfer that it's a polygon and not a polyline. The blanking flag value I have here is a 0, but because we're not using this as a BLN file for blanking, it doesn't really matter. And like I said, I put the object type as the attribute value. So right after the last row of the polygon comes the header row for the next object. In this case, it's a polyline. There are 6 vertices in this polyline, so I have a 6 in the header row, and then I've listed my 6 XY coordinates. The value in column C and in column B in the header are going to be ignored, so I'm just going to leave those alone. And like I said, I put the object type as the attribute value. Now the point object is last. There is a 1 in column A in the header row, which tells Surfer that the object's a point. The attribute values in column C, and again the blanking flag value and the data point value in column C is ignored, so it doesn't matter what's there. So the XY coordinates tell Surfer what type of object it is. If there's only one set of coordinates, then it's a point. If there's more than one set of coordinates, and the first and last set of coordinates do not match, then it's a polyline. If there's more than one set of coordinates, and the first and last set of coordinates do match exactly, then it's a polygon. So let's create a map of this BLN file and see what it looks like. I'll go back to the plot window and click Map, New, Base Map. Select the BLN file and click Open. So I can see my 3 objects in the base layer here in the Object Manager, and I can also see them in the plot window. If I change my map limits a little slightly, you can see them a little bit better. So here you can see the 3 objects, and if I click on one of them, like this polygon, and then click on the Info tab in the Property Manager, I can see that the attribute value that I entered is here for this attribute std ID1. So you can see that the BLN file is really a pretty simple file format. It's just a single header line and then a list of XY coordinates for each object in the file. Are there any questions about the contents of a BLN file? No? Okay. So the next topic I'll discuss is how to create one. So there are 4 common ways to create a BLN file. And the best way is just going to depend on what sort of data you have to begin with and what you want to do with the BLN file. So the first way is if you have the boundaries that you want in another format, like a shape or a DXF file, then you can simply convert the file to a BLN file by loading it as a base map and then exporting the base layer as a BLN file. For example, let's say you downloaded a lakeshore boundary in a shapefile format, but you need a BLN file because you want to blanket grid file to that boundary. So load the shapefile as a base map. I'll click Map, New, Base Map. I'll select my shapefile and click Open. Now, if there were multiple polygons or if there were other object types, you may need to edit some features or do some geoprocessing to the boundaries. But when you're finished, turn off the axes in the Object Manager, then select the map and click File, Export. In the Export dialog, you would want to check Selected Objects Only because we want to export only the base layer. Give the file a name, choose to save it as a BLN file, and click Save. It's that easy. So I'll go ahead and delete this map. Now the second method to create a BLN file is if you don't have the boundaries in another file format. Another option is to simply draw them over an existing map and then export the drawn objects to a BLN file. For example, let me create a shaded relief map. Oh, delete that. All right, so I have the shaded relief map here. Let's say I want to draw some polygons on it to blanket for later on. I'll right-click over the map and click Add Empty Base Layer. Now you can see the new base layer, which is empty, added to the map. Right-click over the base layer and click Enter Group. Now I can draw whatever I like and it will be part of that base layer. So I'll go ahead and draw some polygons. Let's say these are my field areas where I collected the data. And you can see the polygons in the Object Manager under the base map. So draw whatever you like, and when you're finished drawing the items, right-click over the base layer again and click Exit Group. So now you have a base layer with your polygons, and the polygons are drawn as part of the map. Now you would turn off the other map layers, turn off the axes just like you did before, and click File, Export to export it to a BLN file. I'll check Selected Objects Only because I don't want to export the text as well. I'll give it a name and click Save. Here in the export options, I'll make sure that the scaling source is set to map. My file rectangle shows map units. It all looks good. I'll click OK. And then the BLN file is created. So I'll turn the map layer and the axes back on. And then I'll actually delete the space layer that I created. So now we're back to just creating the map. So now, if you just have a few simple boundaries, and you don't want to go through the process of creating the additional base layer, drawing the polylines and polygons, then you can simply digitize them. This is a good way to create a BLN file of a few simple points or lines or even a polygon. Like if you wanted to use it to slice a grid file, this would be a good way to do it. So right-click over the map and click Digitize. Now click on the map, and you can see that when I clicked on the map, a small text box appears up here with the X, Y, and Z coordinates of the location that I clicked. So if you're digitizing a polygon, click around your polygon boundary in a clockwise or a counterclockwise direction. Now when you're finished digitizing the polygon, copy the first set of coordinates and paste it to the bottom. So it starts and ends at the same place, and that creates a closed polygon. Now if you wanted to digitize another feature, just press Enter on the keyboard to enter a blank row here, and then you can start clicking on your next feature, like a polyline for this ridge here. Now when you're completely done, click File, Save, and you can save it to a BLN file. So I'll cancel out of there. Once you've saved your BLN file, you can close the Digitize Coordinates dialog and then press Escape on the keyboard to end digitizing mode. So the fourth way is if you don't have an existing file to import, a map to draw or digitize on, but you know the X and Y coordinates of the vertices for whatever point, polyline, or polygons you want, then you can simply just enter the coordinates directly in the Surfer worksheet and save it to a BLN file. Now this is a good option if you knew the points to make up a section line to slice a grid, the coordinates of a fault file, or if you just wanted to draw some lines on a map using the XY coordinates. For example, let's say I have the XY coordinates for the beginning and ending points for some simple lines that I want to put on this map. I'll open the worksheet window, and here I'll create my BLN file. Now remember, the BLN file consists of a one-line header row followed by the XY coordinates. So to create some simple two-point lines, I'll enter 2 as a header for the two-point line, and then type in the X and Y coordinates for the 2 points that make up the line. So I'll just go ahead and enter some coordinates here. I'll enter the coordinates for another line. I'll do this as fast as I can. And one more line. All right. So once I entered in all the data that I want, I'll just click File, Save, and save it to a BLN file. Get rid of that colon and click Save, and it's created. So now I can go back to the plot window, and I'll add the BLN file to this map as a base layer. And there are my lines. So that's the 4 easiest ways to create BLN files. Load an existing boundary file and then export as a BLN file. Draw the boundaries as part of a base layer and then export the base layer as a BLN file. Digitize the boundary, saving it to a BLN, or simply entering the data directly into the worksheet and saving the worksheet. If you ever did want to edit a BLN file, you can do so either directly in the Surfer worksheet by opening, editing, and resaving the file. This would be easy to do if you just wanted to change the blanking flag value, the attribute, or any Z values. But what is usually easier is to load it as a base map, just like this, then enter the base layer group, and you can add, delete, or reshape the features, or use any of the commands under the geoprocessing menu. Once you're finished, you would exit the base layer group, and then export it out to a new BLN file. Are there any questions about creating a BLN file or editing one? No? Okay. So in topic 4, so now that we've gone over what a BLN file is and how to create one, let's walk through how to use it with the 4 use cases that I outlined before. That is blanking a grid file, using it as a fault file or break line file when gridding, slicing a grid, and displaying boundaries. The first use case I'll go over is blanking. As this is the most common use of BLN files, I'll go over this in a little bit more detail than the others. So to start, I'll create a map of the grid file. It'll just be a contour map. So here are my contours. And let's add a base layer to it from the BLN file that we created in the last topic. So I'll right-click, click Add, Base Layer, select my polygons file, and click Open. So say these are my field areas that we drew and exported to a BLN file, and now I want to blank these contours to these polygons. Blanking a grid file, and hence the map, is a really pretty simple process once you have the grid file and the BLN file. The most common pitfalls for users when blanking are to use the wrong blanking flag value. Remember that a 0 is to blank outside the boundaries and a 1 is to blank inside the boundaries. Or the BLN file contains polylines instead instead of polygons. This is easy to verify by creating the base map of the BLN file, like we did here, just expanding the base layer and then checking out the contents here. If there are points or polylines in there, the grid can be blanked in an unexpected way. The next pitfall is if the BLN file contains x and y coordinates that are not in the same range as the x and y coordinates of the grid file. For example, if the BLN file was in lat long coordinates and the grid file is in UTM coordinates, in this case the polygons in the BLN file aren't even near the grid nodes of the grid file, so either nothing will be blanked or the entire grid will be blanked. So lastly, getting the BLN file in the correct format when blanking outside multiple polygons. Now this isn't a problem when blanking inside polygons, it's just a problem when blanking outside multiple polygons. For example, in this map, I want to show the contours inside these two areas and have the map be blanked outside of the polygons. I have my BLN file, it contains the polygons, and the polygons are in the expected locations on the map. Everything looks good, but the problem here is that if I have it set in the BLN file to blank outside the polygons, then polygon 1 is outside polygon 2, so it would be blank. And then polygon 2 is outside polygon 1, so this would be blank too. So it turns out the entire map would be blanked, and that's not useful for anyone. So in this case, we must combine the polygons into a complex polygon. You can do this either in the worksheet or in the plot window. It's much, much easier to do it in the plot window, so that's what I'm going to show you now. To do this, you would right-click over the base layer and click Enter Group. Then all you do is select the polygons that you want to combine, click the Geoprocessing menu, and click Combine Islands List. And that's it. So now you have a single complex polygon that has both of these individual polygons in it. So I'd exit the base layer group, turn off my map layer and axes, and click File, Export to export this to a new polygon. Or I'm sorry, a new BLN file. Make sure the scaling source is map. I have map units, click OK. And then I'll go ahead and turn the map items back on. Once you have the BLN file in the correct format, blanking the grid is actually very, very simple. Just click Grid, Blank, select your grid file, click Open, select your BLN file. I'll be sure to select the one with the complex polygon in it. Click Open. Give the blanked grid a new name. And click Save. I'll save the spatial reference information and click OK. And then I get a little note that it's been blanked. Great. So now I can create a new map or update the existing map with the blanked grid file. I'll just click on these contours, click on the Open Grid button here, select my blanked grid and click Open. And I can see the contours only inside these areas that I blanked. Now it's that simple. Are there any questions about blanking a grid file with a BLN file? All right, so then we'll go on to some of the other use cases. I'll go ahead and delete this map. Now the second use case is to use a BLN file as a fault file when gridding data. So faults act as a barrier to information flow. This could be a concrete wall or any other impermeable barrier, like an actual fault with fault gouge. So let's say I have a data set that I gridded. I'll create a contour map from the grid file. And let's say I created a BLN file of my fault lines. I'll go ahead and add it to this map. So here are my fault lines. I'll actually go ahead and make them red so we can see them a little bit better. So now let's regrid the data and use the BLN file with the two polylines in it as a fault file. I'll click Grid Data, select the data file, and click Open. Not all gridding methods support faults, but minimum curvature does. So I'll keep the gridding method set to minimum curvature and click the Advanced Options button. Click on the Break Lines and Faults tab, and then add the faults file. Click this button, select my fault file, click Open, and click OK. I'll change the file name, and then I'll click OK, and the grid has been created. Now I'll create a new contour map, and you can see how the faults have influenced the resulting contours. I'll make these maps a little smaller so we can see them all together. This is the original. And so here's the data gridded with no faults, with the fault lines just overlaid on top. This is the data regridded with the lines as faults. And here you can see the contours go right into the faults. Now let's use the BLN file as a breakline file instead and compare it to how it looks to the faults. Now a breakline is a change in slope or a linear feature of known z value. Because the linear feature has a known z value, all the vertices in the BLN file do need z values. This BLN file that I've been using, I'm going to open it up in the Surfer worksheet. File, Open, select it, and click Open. And you can see that I did add z values to each x and y point in those lines. Now the z value doesn't all have to be the same. I've made them all pretty much different for the different vertices in the line. So to use this as a breakline file, I'll click Grid Data, select the data again, and click Open. I'll keep the gridding method set to minimum curvature, click Advanced Options, click on the Break Lines and Faults tab, and this time add the BLN file as a breakline file, not a fault file. Click OK, change the output grid file name, and click OK. And the grid file has been created. Now I'll create a contour map of this grid file and resize it. So here they are with faults. You can see the contours go right into it. Here you can see the lines have been used as break lines, including the z values, which is used in the gridding process. And the contours are very smooth around those break lines. So are there any questions about using BLN files with faults or break lines when gridding data? Nope. All right. We'll move on to the fourth use case. And this is to slice a grid file with a line in a BLN file using the grid slice command. So I'll go ahead and delete these maps that I created. So when you slice a grid file, the BLN file would only have one polyline in it defining the line of section. So let's create a map of Mount St. Helens. Move it to the side. So I'll create a BLN file by digitizing my section line. I'll right-click, click Digitize, and let's say I want the section line to go right through the center of the crater. So my starting and ending points, this will be my section line. I'll click File, Save, and save it to a BLN file. Click Save, close that, and then press Exit on the keyboard to exit the digitized mode. Now let's say I want to actually display the section line that I just created on this map. I can add it as a base map or a base layer. So I'll right-click over the map, click Add, Base Layer, select the BLN file, and click Open. And there's my section line. So now let's go ahead and slice the grid file. I'll click Grid, Slice, select my grid file, and click Open. Select my BLN file, and click Open. And here we have a choice to output a BLN file or output a DAC file. Now the BLN file actually isn't very useful. All you get out is the X and Y coordinates along this line, and that's not what we want here. So when you're using grid slice to create a topographical profile, you want to output the DAT file. I'll click this button here, give it a name. Choose to save it as a DAT file and click Save. Then I'll click OK, and the slice has been created. Now to display the slice data, it's best to convert the DAT file that we just saved into another BLN file and display it as a new base layer. So that brings me to the last use case scenario, and that is to simply use the BLN file format to display points, lines, and polygons on a map. So we've shown how to load BLN files as base maps a few times already in this webinar. So in this section, I'll continue with the previous example and reformat that slice data to a BLN file for display. So I'll click File, Open, select the data file, the slice data that we created, and click Open. Now it opens in the worksheet. Now I want to format this data as a BLN file to show my slice data. The columns here, the resulting columns are X, Y, Z, distance along the section, and then just a 1. So I want to display a topographical profile, which usually has distance along the section as a horizontal x-axis. And since this is a BLN file format, it requires the X data to be in column A. Therefore, I'll cut this column, column D, with Control X, highlight column A, and use Control V to paste it in. Now the BLN file format also requires the Y data to be in column B. In profiles and topographical profiles, the Y data is usually actually the elevation. So I'm going to cut column C and paste it into column B. And column E can be ignored. It won't be used at all. So now the only thing I'm missing is the header row. So I'll go ahead and highlight row 1 and click Edit, Insert. This will be my header row. Now in cell A1, I want the number of data points here. So that's pretty easy to find out. I'll just scroll down. Look to see the last row. It's row 538. But the first row is the header row, so there's only 537 data points. So I'll enter 537. And that's it. I'll click File, Save As, and save it as a BLN file, not a BNA, a BLN, and click Save. Then I can go back to my plot window, here it is, and load it as a base map. So Map, New, Base Map, select my BLN file, and click Open. And there's my topographical profile for that section line. Now, are there any questions about using a BLN file to slice a grid file, or using BLN files as base maps to show points, polylines, and polygons? No? So someone asks, now why wouldn't I use a profile? So another command here is if I right-clicked over this map, I could click Add Profile and pretty much do a very similar thing. Select my 2 points with my line, and the profile is automatically created. Now, why would I do the grid slice command instead of creating a profile? The profile is a really great and easy way to create a cross-section. However, there's a couple things that are different here. You can't tell Surfer exactly where to start the profile starting and ending points. If you really want your cross-section to start exactly at this point and exactly at that point, a BLN file is much easier to do that because you enter the coordinates directly into the file. With the profile, you can zoom in and try to click in the same spot, but you may not get quite the accuracy that you need. In addition, profile objects are also really handy and quick to use, but they can only be used on one grid file. So you can create a profile for one grid file, a profile for another one. There can only be one line in each profile. If you have multiple grid files, like for different geological horizons or different structures, you can slice all those grids with the same BLN file, modify the DAT files that you get, into a BLN file and then overlay them all together to create a cross-section. So you can't do that with profiles. There's only one line per profile, but with the grid slice command, you'll end up with a BLN file, which you can then create base maps and overlay together. So it really depends on what you need. If you just want an easy way to create a quick section, profiles are great. But if you need it to be exactly starting and ending at the same exact points, or if you want to overlay multiple profiles together, then grid slice would be a better option. Are there any more questions? Okay. Are there any other questions about any part of this webinar that wasn't already answered? Okay, so this concludes my presentation of using BLN files for blanking in Surfer. If you have any additional questions once the webinar is concluded, you can call our technical support phone line at 303-279-1021 or email questions to either surfersupport@goldensoftware.com or email me directly at Carrie, that's K-A-R-I, @goldensoftware.com. Again, a recording of this webinar will be posted shortly on our website at www.goldensoftware.com. Thank you for your time.